project and describe how reinforcement learning was applied. At a high level, our goal was to determine how multi-agent interactions can influence traffic flows. To do this, we had to determine the best model for creating policies that reduce congestion. The metrics we planned to collect were the rate of vehicles coming into the road network, the percentage of AVs out of total traffic, the frequency of lane changes by human drivers, and the actions taken by the AV. All our experiments were conducted within Flow, which is a Python framework to quickly develop custom simulations for the CMO traffic simulator. Flow is also allowed us to leverage distributed computing and RL libraries to run our experiments. We utilized two different POM-DPs for training. The first one was built into Flow. The state space consisted of the ego speed of the AV, the speed of the leading vehicle, and the distance of the leading vehicle from the AV, the speed of the following vehicle, and the distance of the following vehicle from the AV. The action space was continuous and consisted of either slowing down or speeding up on the AV's side. The reward was the weighted sum of divergence from the desired velocity of the road network and the current velocity of the AV, and the distance from the leader. We developed a custom POM-DP. The state space was again the speed of the AV and the leader and the distance from the leader, but this time we only accounted for the distance to the nearest merging lane, rather than the distance from the follower. The action space was the same, and the reward was only the divergence from the desired velocity of the road network.
So we did a total of 5 experiments in our project. First one was creating a baseline for ring and merge scenario. Later, we stabilized this ring and merge scenario using the PPO algorithm. Later, we did the analysis of the merge scenario to check if whatever results that we got, were they statistically significant or not. Once we got that the results were statistically significant, we came up with our own modified state space, like Isaac said before, of taking the distance of the nearest merge lane, and we trained on this modified space. We got further improvements on this. Then we used this novel state space to train on the simulated map of I696. So for the ring scenario, in our baseline, the reward that we got was 1559 and the average speed was 3.59 meter per second. After training it using the PPO algorithm, the reward increased to 2414 and the average speed increased to 4.46 meter per second. For the merge scenario, the average speed was 11.18 meter per second with a reward of 254. And with the trained policy, the average speed increased to 12.66 meter per second with a reward of 319, thus seeing a 13% improvement. Later, we went on to do the statistical analysis of our results. So in this plot, the blue line is the velocity distribution for the baseline, and the orange one is the velocity distribution for the trained policy for over 100 rollouts. And we can clearly see that the distribution was quite different. Now in our further analysis, we want to see if we can reduce the variance of the trained policy, but that is the next step of action. For the modified merge scenario, where we incorporated the distance to the nearest merge lane point, we saw that as compared to the scenario, the custom state space that the flow paper gave, we got even a marginal improvement, increasing to 13.02 meter per second, and the reward increased from 319 to 324.
So we trained the I696 scenario with the novel POM-DP and only included two inflows, the inflow on the main highway and the inflow on the merging lane for simplicity. The distance to the nearest merging lane was also fixed to be this junction right here. With this setup, we achieved an average reward of 69.05. We plan to compare this to the baseline I696 scenario, which used the default POM-DP. Our future plans include computing distance of any merge lane that an AV can encounter along the highway. We will train and stabilize I696 with this new setup, and we will train and stabilize I696 with more than 2 traffic inflows. We will also add a lane change to our action space and utilize TAC resources to run more experiments and produce more results faster.